Hello and welcome. I'm Bryden Oliver and I'm going to be presenting tonight's user group. So, what am I going to talk about? So I'm going to be talking about database performance for developers, and I've called it Do You Have a Plan? Because we're going to talk a little bit about query plans in here. Okay, so who am I? I'm a SSW solution architect. I've got 20 years of experience in database performance. Most of that was writing database performance monitoring tools in my previous job. I've worked with Azure since it launched. It'd be almost 15 years ago now. I'm a little bit shorter than I used to be after an unfortunate trampolining accident. I have used Azure at massive scale. In that database performance monitoring tool, we were getting in enormous amounts of data. And as such, I know quite a lot about Cosmos DB, especially about how you can manage its cost at scale. Okay, so here at SSW, we've got a rewards app. So if you scan that QR code there, you can install the SSW rewards app, and at the end of this presentation, there'll be another QR code that you can scan to get some points and maybe claim some cool rewards. All right, so tonight we're going to cover the following. So I'm going to go through a quick intro of what we're doing and why we might want to do it. Then we'll look at how SQL Server executes your queries. We'll then look at SQL Server execution plans and delve into them a little bit, see how we can get them and a few things like that. We'll then talk about a few things about monitoring and how we can find out what the expensive queries are. And then we'll talk about selecting appropriate indexes, because selecting appropriate indexes gives you by far the most control over SQL Server performance with the absolute minimum of effort. And then we'll just have a quick summary of basically the key points we've covered as we went along. So let's have a little bit of a think. Most of us are developers, so we write some code and then we let it run, and eventually it ends up calling SQL Server. And for a lot of the developers, that's as far as it goes. They don't know what happens after that step. So tonight we're going to have a look at what it is that does happen after that, and whether we can understand what it is that happens after that and use that to help us improve the performance of our applications. And can we improve that? And what are the techniques we can use for improving that? So we're going to cover an awful lot of ground tonight. The whole presentation is in GitHub. All of the demos are too. And there's the GitHub address. I will upload it onto that address after the presentation. But first, I'm going to have a little bit of a talk about why we talk so much about indexes. And that's because it's by far the easiest way to reduce I/O and CPU pressure in SQL Server and any other database. And basically all that databases are doing is pretty much, it's all I/O and CPU. The other thing about indexes is, as a topic, they're relatively easy to understand, and we'll see all this in the demos later. But before we start, I'm going to tell a little bit of a story just to give you an idea of why you might care about this sort of stuff. And it sort of covers the techniques we're going to look at tonight. So, in the last few years, I had a very large client, and they had an enormous amount of data that was all stored on-prem. And basically, they wanted to create a new cloud-based application, and they needed all the old data, so 20 years of data brought in as part of that process. So we went and built this application for them. We got it running, and it was running nicely in the cloud. And then we got up to the part where we were bringing in the old data, which was also on SQL Server. So step one, we copied all of that SQL Server data into the cloud. And then we started doing some testing on transforming all that data to the new format. And so I spent 2 or 3 days doing a little bit of testing and figuring out, what was involved. And I had to call a meeting with the client and say, and it was a bit of a long meeting, because what happened was I was able to say, well, we managed to copy all the data from on-prem to the cloud. That's all good. And I've started working out how we're going to transform the data to your new format. Now, I haven't done any optimization yet, but I do know what the longest time it could possibly take is if we don't do anything about this. And unfortunately, that's going to be quite a while. And I sort of got blank looks and I said, that's going to be really, really quite a while. And at that point, the looks sort of changed, and a couple of them started asking, so what does quite a while mean? So I realised I was actually going to have to give them the numbers, and it took a while for them to draw this out of me, and eventually I was, well, based on my calculations, it looks like it's going to take something like 43 years to get your data in. At which point there, so I said, can we have a couple of days to try and do some performance optimization? And we sat back and used the techniques that I'm going to present here. And after that 3 days, I was able to come back and say, yeah, we've managed to improve things a bit. So we've really got it down quite a bit. I think you'll be reasonably happy with the outcome. And they're all looking at me expectantly. And I say, well, it's going to take about 3 hours to complete. And sort of shocked faces, like they were expecting some massively larger number. But that gives you the order of magnitude improvement you can get with some of these techniques. You can get 100,000 times performance improvement, potentially, as we go. And we'll see some of these improvements in the demos. So some of the demos are of that order of magnitude, and they're quite simple techniques. All right, so let's start by having a look at what happens inside SQL Server. So here's what happens when SQL Server executes a query. This is a very simplified view, but there's basically 2 key parts. There's the SQL engine, which takes your SQL, turns it into something, and then decides how it's going to be executed. And then there's the storage engine, which actually goes and gets the raw data off disk or memory and brings it back and gives it back to you. So what we do is we compile the query, which is pretty simple. Then we optimize it to try and figure out what are the best steps to take to actually build it, to get you the data back, and then we execute it. And as it happens, it then passes instructions to the storage engine, which then executes all of the things in your query. Okay, so there must be more to it than that. Well, some of the key things we want to know is that piece that the SQL engine uses to send stuff to the storage engine, that's called a query execution plan. So what's important about that? The fact is, those get put in a cache, and that cache is called the plan cache, which, if you've seen memory usage in SQL Server, quite often it'll tell you about how much space is being used for your plan cache. And that's what the plan cache is for, is caching the queries that have been executed before, so we've got a new plan and we don't have to optimize it again. So this is just adding a little bit to our previous diagram, we're just adding in the plan cache. So if we get a query in, we look up the plan cache. If it wasn't found, we go through the steps we had before. Otherwise, we just come straight down to the execution step, skip the compilation and the optimization, and we execute the same set of steps we did before. And that's useful for a whole bunch of reasons. That means that if we run the same plan again, we can sort of keep statistics about that plan and how long it takes to execute. So that's very useful, that it categorizes them so nicely for us. Okay, so now we're going to start looking at those execution plans we saw. And why would we care about them? Like, I mean, it's all great that SQL Server knows what it's going to do, but the real beauty of execution plans is that SQL Server can tell us what its plan is. It can give us back that list of instructions and we can get some information out of it. And those plans tell you heaps of interesting stuff. I mean, initially you might just look at what the steps are, but there's all sorts of interesting information in there. So let's dive in and we'll do a quick look at that. So what we want to do is I'm going to show you how to include plans when you're executing SQL. So this will be in SQL Server Management Studio. Then we'll have a look at how we can view a plan. And there's various ways to view a plan. The most common way is SQL Server Management Studio, Plan Viewer. But the plans come back and are rendered in that based on a raw XML format. You can also get that. The reason that I'm mentioning that one is there's more data in that than the UI that Management Studio gives you. So you can get a little bit more information in the very rare cases that you need really, really specific information. And here's a plug for a product I used to work on called Spotlight Tuning Pack, which when you execute a query, you can get back the plan and it gives you a much nicer user interface. The only problem is you have to use a very old version of SQL Server Management Studio. Anyway, choose the way you'd like to view them. And I'll just mention I'm going to use the SQL Server Management Studio Plan Viewer throughout this session. So let's jump to SQL Server Management Studio. And what we do is there's this button up on the toolbar here that says Include Actual Execution Plan. So it's basically an on-off toggle, so I just click it on and let's execute a query. And this query takes a little while to run. So before we go too far, I'll just pop open the databases list here. And we can see I'm using the Stack Overflow 2013 database. So this is all of the stuff that was uploaded to Stack Overflow over the period up until 2013. And it's a great data set for testing and learning about indexing and performance. Anyway, it's come back, and you'll see we've got our results for the query. We've got some messages, and we've got this extra tab that we don't normally get called Execution Plan. So let's have a look at what's in there. So what we get is, and it goes from right to left, each of these steps gets going through in order and they aggregate towards the right. So if we look, the first thing it's going to do is a clustered index scan of PK votes ID, and it's going to grab out the user ID out of that. So that's clearly this piece of the query here. And then on this side, we've got the user index on the users. But as you can see, you get all sorts of interesting stuff here. So that cost column on some of the items tells you what proportion of the execution time of the query is being caused by that particular piece of the query. You get how many seconds it took. If you bring up the flyover hint, you get all sorts of cool statistics in there. And we'll talk about those in a minute, what those statistics are and which ones are most useful. Okay, so that's a demo of how we get a query plan when we're just running raw SQL. So let's have a look at what those statistics were that were available in there. So we've got the execution count, which is kind of useful. So it tells you how often that particular step gets executed, how long it took, and then the 4 here in bold are the ones that are most useful. So most often we look at the CPU time, and this is the critical one in my view, the logical reads is the most important of the statistical numbers, and then logical writes and physical reads, which can give you some other useful stats. And then there's a bunch of other ones. CLR time, so if you've got some script executing in there that's hitting the common language runtime, that'll tell you how long that took. You've got degree of parallelism, so that'll tell you if that piece of your query is running in parallel, so whether it's being run on multiple CPUs on your server. You can see how much memory you've consumed. So if you do end up in a situation where you've got a memory constrained SQL Server, you may look at that memory consumption one, but generally you don't need to worry about it too much. Then you've got a row count and some other memory statistics, which very rarely would you ever find them very useful. Okay, so now we've looked at execution plans. How about finding out what's going on? And the key thing we want to know is which of those statistics is important on our server. And that kind of depends. What you really want to know is, before you start searching for particular problems, is what resources are constraining my SQL Server. So most commonly on a SQL Server you'll find it's either CPU constrained, which means it's using all its CPU, but if you were reading anything from disk, there's plenty of disk I/O left. Or the more common one is it's what's called I/O constrained, or under I/O pressure, where it's reading stuff from disk and really the CPU is having no trouble keeping up and it's able to process everything it's getting off disk quite fine. That's the most common scenario in SQL Server. And how can we find out which of those it is? And what could we do about it if we did? So let's have a look at how we can get some of those numbers and figure out what's going on. So let's flick back to Management Studio. And where you can find this very quickly and simply is you right click on the server, and if we head down to Reports, Standard Reports, there's a performance dashboard down here. And if we wait, that performance dashboard will come up. And well, here's the first one. If we want to find out if it's CPU constrained, this chart here on the left shows us how much CPU is being used both by SQL Server, which is the SQL, and other. So that gives us a good way of knowing that whether it's CPU constrained or not. Clearly this one isn't, because everything's using 0%. Now if we want to know whether we're under I/O pressure, we can head down into this historical information, and there's 2 sections we can look at. We can look at the I/O statistics, and this will tell us some numbers, and we can see what percentage of total I/O is going to various servers, and we can also see what's going on in all of the other places. Like we can see which particular databases are consuming large amounts of CPU, and we can see which ones are consuming large amounts of I/O, and whether it's read wait time or writes or whatever. And if we go back, we also have this wait statistics one. And what this is a cumulative amount of time that SQL Server has waited for various things. And on this server, it's under Other, but you'll see we've got buffer I/O, network I/O, transaction log I/O, and other disk I/O on these charts. So they all tell you an awful lot of information about how much I/O is going on. So if those numbers are high, then you've probably got a CPU constraint, an I/O constrained server. Okay, so now we sort of know what type of pressure SQL Server is under. How can we get plans to try and figure out which things are causing that pressure? So we've already seen one of those, which is when we included that actual execution plan and ran a query. The second one I'm going to show you is how to get to the query store in SQL Server Management Studio. And on newer versions of SQL Server, query store is turned on by default. If you've got an older SQL Server, you may need to manually turn that on, and I think that is found under the properties of your server down here. But I'm going to go to a database and take a look at the query store for it. So the thing I would always use here is view top resource consuming queries. And what we get is a chart of all the queries that have run. We've only run one query recently in here because this is looking at the last hour. And surprise, surprise, the plan sitting down the bottom is that query we just ran. So we found our query. So we knew that we ran that query, 10 or so minutes ago. And it's giving us the plan for that automatically. But what you'll see is if you click on, if there were more items in this chart, you can then click on the slightly less consuming ones. The other thing that's worth calling out here is this configure button. And you can choose to order it by CPU time if you're CPU constrained, or logical reads if you know that you're IO constrained. And that gives you a good way of being able to pull out the queries that are actually causing the thing that you're constrained by. Okay, so that's how you can find out which queries it is you might want to optimize. Okay, and let's just cover a couple of other useful little tricks before we get into some demos. It's really useful when running locally to be able to get query statistics, particularly IO statistics, because that's the key thing you always seem to be trying to optimize on. So at the top of your query, add the following: set statistics IO on, and that will collect some IO statistics and give it back to you in the messages along with the results of your query. And I won't demonstrate that now because we'll see that in every step of the demos. I use that extensively to be able to show you exactly the performance improvements we're getting, because we can then see them. Okay, there's a bunch of further techniques that we can learn about, and we're talking about things like DMVs, which are also called dynamic management views. We've got SQL Server Profiler, Query Store, which we just had a chat about, extended events, which is a way of logging other types of events in SQL Server, and it will log them away like deadlocks, and it'll record the tree for you. You can get weight statistics, which we saw in that chart. You can get locking and blocking type information. They're typically available in DMVs, but expressed as something called a locking tree or a blocking tree. They're very useful because it shows you what's being blocked by what, and you can get to the thing that's doing all the blocking. And then deadlocks. And I'm putting together an advanced SQL Server performance session similar to this that covers a range of these sort of techniques. So watch out for that. But now we'll get up to the what you can do. So far all we've figured out is what is causing our SQL Server performance issues. We've still got no idea what we're going to do about them. So now we're going to get into that. So we're going to try and pick some good indexes and try and get that sort of performance improvement. So the thing with picking good indexes is the first step is being able to relate things to the real world. So to visualize what an index looks like and how it works. The second thing we'll have a look at is how we index where clauses. So when you're trying to constrain your select query, how we can write indexes to improve that. And then we'll look at how we can test our index changes, because that's critically important. And then how we can index order by and then indexing joins in our queries. So when we're relating it to the real world, the obvious analogy is a book index, and that's in fact where the name index comes from, is because they were trying to imitate a book index or a library index. And if you make a book index, try and execute some queries with it. And let's have an example here. So this is a page out of one of my relatively distant relatives, Sir Jamie Oliver. And this is the index to one of his cookbooks. And it's indexed by ingredient and then by recipe. So I can look up, say, octopus. I come down to O, find octopus, and then I can quickly find recipes under there. And if I wanted a particular recipe, I could find the ingredient and then find the recipe very quickly in that list. And you can really understand quite easily in there how you would look stuff up. And that's the same way SQL Server is trying to look stuff up for your queries. But if you've don't have an index or a bad index, it might have to read every single line on this page to figure out the information you wanted. And that's what we're trying to avoid with indexing, is avoiding having to read everything. Okay, so we're thinking we're going to create some indexes. How can we visualize what's going to be in the index and how it's going to look? So you can actually write a select that basically mirrors and gives you back as the results what your index is going to look like. And then you can try by hand trying to find the information you were going to ask for. So here I'm about to create an index, and its name's going to be ix name date, and it's going to be on the badges table, and it's going to have name and date in the query. So if I write select name date from badges, order by name date, so in other words just the two fields repeated, I get back exactly what that index looks like as it's stored in the index in SQL Server. And what you get is something that looks a bit like this. So here's you can see it's all in grouped by name, and then the dates are in order. And if we want to find something like this SQL statement down here, I'll replace SQL Server with .htaccess because that's all I've got on the left there. I can very quickly find the count. I can just count those. There's 31 of those. Max date and min date. That means I've got to go to the first row and the last row and grab the date of each, and I've fulfilled my query. And that was all I had to do. I didn't have to read, say there was a million rows there. I just had to find my way to this block and find the first one and the last one in the block, and I'm done. That's why indexes can be so powerful, is that they can allow you to avoid scanning the whole table. Okay, so this is the simplest case, and we're going to look at how we index an order by. And all you have to do is just drop the order by into the index definition. So let's see that in action. So if I'm selecting the display name from the users table and I want it ordered by display name, I just create index ix display name on users brackets display name. So I've just put the order by straight into the index. So that's nice and simple, that one, isn't it? And now we'll look at how we can test indexes. So if I wanted to, this highlighted piece here is with brackets index equals 1. This is what's called a compiler hint. And it says for this table users, I want to use index 1. Index 1's the primary key on a table. So that means don't use any of the other indexes I've defined. Use the primary one. Or this second case says use the index named ix underscore indexes. Or sorry, ix underscore index. So that's use a particular index. And that's super useful when we come to test stuff, because we can test, if we've created a whole bunch of indexes, we can test which one of those index candidates is the best. Okay, so now we're going to do a couple more demos, and they're all about indexing where statements or where clauses. The first one, we're just going to look at a single comparison, and then we're going to look at where we've got multiple items in the where statement, and then what happens if you invert it and it's an inequality. Does that change our approach? Okay, so let's get rid of a few windows here. And here's our first query. So what we're going to do is, and we're in this Stack Overflow database again. Whoops, I haven't flipped that one across. So what we're going to do is select ID, display name and location from the users table where the display name's Frank. So let's just give that one a try. Okay, and we've got an execution plan. So let's go and have a look at the execution plan, because that'll give us an idea what's going on. And wow, look at that green bit down there. SQL Server suggested we create an index to do this. I reckon we should try that one, because sometimes SQL Server selects a good index, sometimes it's not so good, but let's try that one. And here's the first time we're going to have a look at that statistics IO on that I talked about. So I'm going to set statistics IO on, and then I'm going to run my select statement, and let's see what happens. Well, if we come down here into the messages, you'll see we get this. And for me, typically I look at that logical reads number, and that's pretty much the key one if you're trying to optimize particularly select statements. They're always reads, and the amount of physical reads don't matter too much, because that's just data it had to read from disk. If you rerun the query, it won't have to read it from disk, because it'll be in the what's called the buffer cache. So typically it's the logical reads that matter. Okay, so does anyone think we could do better than that index? So remember, we're looking for ID, display name and location, and we just created an index based on display name. Well, I think we could do better because of what SQL Server is going to have to do here. What it's going to do is, if we've got an index based on display name, it's going to run down the index, find all the ones that match the display name. Another key thing is the index will then have the ID column, which is the primary key of that table. So we'll have that in there. And then it's got to go back to the main table and read all the locations out. So that says to me, if we'd had the location in this index, we wouldn't have had to go back to the main table, and that would be more efficient. So here's how you do that. You can include columns in an index, and that means they're stored along with the index, so you don't have to go back to the main table. So if we execute that and create that index, and I might just stop before I go too far and talk about the naming conventions for indexes. So the naming conventions I tend to use are the same ones that Brent Ozar uses everywhere. And I really like his conventions. He's a very prolific trainer in the SQL Server industry, and we see him a lot. So anyway, we'll talk about him later, because I'll point out lots of resources he supplies and quite a few others. So now we've got two indexes we've created. Now we can see what happens. Well, let's first of all just try executing that and see which index it did use. So we got an execution plan back then, and let's see. It used ix display name includes. So that's the one we just created. So it looks like SQL Server thinks we did a good job, but I'm not 100% sure that that was the best one. So let's go and test. So we'll just grab all of this, uncomment that out. And if we execute that, you'll notice I'm using that with index equals. So the first one I do is with index equals 1. So I'll use the primary key only as a baseline. Then I'll use the first index we created for the second run. And then the second index we created for the third run. And then we go to the messages. And if we look here, this is where we start seeing some of the improvements we're getting. So if we look at the first statement's logical reads, it did about 45,000 reads. Then our second one, where we had to go back to the main table and read some data back, that had to do 2,000, just over 2,000 logical reads. And then our third one, where we brought the location in as well, that's gone down to 6 logical reads. So that index there was the winner, and that was really quite a simple piece of testing we did, and that's nearly 10,000 times better than without the index. Now, we've now got an unused index, and remember that every index that you've got, whenever you modify the table, SQL Server has to go and update that index, whether you're using it or not. So we should keep our database tidy and not have any excess indexes about. So we only want to keep one of those indexes. So we'll get rid of the one that didn't win. So we'll just drop that one. And that was how you can do design an index for a simple where statement. So let's get a little bit more complicated. So now we're selecting ID, display name and location. And in fact, the query is identical, except that we've got the location specified as well. So let's execute the query. Let's select the database first and then execute the query. And you'll see we get back 6 rows. And it didn't take very long, but if this was a bigger table, this would matter more. And we can have a look at the execution plan. So it looks like it's not too bad. And let's visualize why it might not be quite so good. So if I run this little piece here, you'll see that I'm looking for Frank and the location of United States in my query, but here's what I would get back if I used the index. I would get Frank, and I'd have to look for all of these United States one by one, and the 6 of them spread through however many rows, 700 rows here. So I'm going to have to scan 700 rows to find the right ones. That doesn't seem that great to me. And yeah, so it's not really that great. So let's think about what we can do. If right now we've got the location included, it's not ordered by that. So what we want to do is bring the location into the index, into the ordering part of the index. So let's create that index, which orders by display name and location. Okay, so let's try that one. And let's uncomment out our code and execute it again. Do we reckon we could do better than this one? So right now we've got 4 logical reads. I mean, it does seem unlikely we could do better, but maybe we could. So if we think about it, what we're doing now is we're finding all of the Franks in, and then all of the Franks who happen to be in the United States. What would happen if we did the opposite? We indexed by United States and then by Frank. And this is where we get to a a concept that we call selectivity. So I'll go back to the slides and we'll just quickly talk about what selectivity is. So selectivity is the proportion of rows in a table or an index that match a given predicate. And it's calculated as the number of rows with a given value divided by how many rows there are in the table. And what we want typically in an index is our selectivity to be as low as possible. So we want to be able to get really tight to the rows we want. So the opposite of this term is what's called cardinality, which is the number of rows that have a particular value. So now that we understand that one, let's jump back to the demo and let's maybe do the opposite. So we looked for display name, then location. So let's create the opposite index and index by location and display name. Okay, so that's going to take a little while to generate. So if you think about it, I can't really guess which one of those would have higher selectivity. When I wrote this, I thought user would, but you know, in this sort of thing, you'd be guessing. So what you would do is, as we did the first time, let's test it. So that's the golden rule with all these things. Test it. Don't just assume everything, just test it quickly. And if we have a look, well, we're doing 45,000 logical reads for the first one again. So using the primary index is really bad. And then the second one is 4 reads. And the third one's 4 reads. So there's not really a logical winner. So we could just pick either of those. And given that we've already got something that needs the display name and then the location, that's the one I'd keep because that's also serving our first query that we were optimizing for. Okay, so let's get rid of one of the indexes just so that we don't have excess indexes around again, because as I mentioned the first time, we don't want any extra indexes. Okay, so now let's think about inequality comparisons. And this is where the selectivity sort of comes in a bit more strongly, because typically inequalities have very high selectivity, which is not what you want. So if we get rid of all our indexes again, and some of these we've already got rid of, and then we run our query here, oh, and we're in the wrong database again. Okay, so if we look at the execution plan, it's doing quite a bit of work, and we didn't collect any stats, but let's try the 2 indexes we created last time just to see what we get. Okay, so create both. Ooh, did I already run that one? I think I hit F5 twice. So now let's uncomment again and we'll execute this one again. And let's see, 9 logical reads. And which one did it pick? It picked display name location. So location seems to have high selectivity and display name still low. That's what I think would have happened, because normally an inequality will have much higher selectivity. But, you know, let's find out just how big a difference it is between the 2 indexes. Okay, let's uncomment and execute. And as you can see, we're going back to these stats again. And that one's got 9 logical reads, and this one has 4,500. So clearly, the inequality had higher selectivity and was therefore less useful in the index. So you're much better indexing by the one with low selectivity first, which is typically the equality. Sometimes it won't be in your data. This is why you test. So there will be cases where maybe the people who are outside the United States are very unusual, and therefore you've got very low selectivity. So for instance, if it was the Australian a database of every person who's got an Australian passport, there'd be very few people living outside Australia who fitted that. So this sort of query would have low selectivity for location is not equal to Australia. Okay, so let's again clean up afterwards, and we're done. So the next one that we might want to do is we've seen how to create an index that uses order by and how we would create an index for where clauses. What about where you've used both? Well, the answer is typically you would put the order by at the end, because SQL Server will do the where first and it will do the order by once it's finished with the data. So you'll want the data in the order that you want it last. And finally, let's see how we can handle joins. So this is where we're joining two tables together. Okay, so let's take it. This is a pretty typical join query. So let's have a look. We're grabbing the display name out of the user table and the creation date and text out of the comments table. And we're going to look for display name equals Unearth Kafka. And the reason I picked Unearth Kafka is he's a friend of mine. He talks widely on AI and entity framework, and we're hoping to run a workshop version of this presentation with entity framework and other advanced DB topics. Keep an eye out for us talking on both of those. JK does lots of talks on entity framework in particular and how to get better performance from the entity framework side. So that goes well with the techniques you can see here. Anyway, let's run our query and switch to the correct database first. And you'll see this is a bit of a longer query. And we'll have a look at our execution plan first, and you'll see that 97% of the time is in this clustered index scan here. So let's have a look at what that is. That's where it's looking at the comments. So it's scanning the comments one. So it looks like the comments table needs an index. And ooh, look at that. SQL Server's suggested an index for us. Okay, let's try that index. But before we go too far on that one, I'm going to go and have a look at the comments table, because I've got a sneaking suspicion about that text column. So let's go to comments, and it's told us to include the text column. And if we look at the definition of that text column, that's set as an nvarchar 700. So that's potentially a 1.4 kilobyte value in there. That seems a bad thing to have in an index, which you want to have really small, tiny rows so that you can fit lots of them into each page that you have to read. So I reckon it might be worth trying this index to see if we can save some space in the on disk and save SQL Server having to read so many pages of index. Okay, so that one doesn't take very long. So now let's go and test these indexes. And we'll uncomment and execute, and it's going to run 3 times. And that first time is going to take quite a while because that's much slower. Okay, so this is one where if we take a look through here, the users table, we don't do a lot. And then, oh, that's 1 million logical reads there. That's a bit more than we've been doing previously for any of the queries. Okay, so our second one that includes the text in it, that does 10 logical reads out of comments and 3 logical reads. So that's 13 compared to 1 million. So that is that 100,000 example I mentioned at the start. We've got 100,000 times better performance here by adding that index. And then the third one, where we had what we think is a much smaller index on disk, that's taken 19. So 13 versus 19 logical reads. I think it's worth having a look at those two indexes and see what the sizes look like. So this is how you would go and do that. So you would go to the index, right click on properties, and you'll get up a page. And if you go to fragmentation, you'll see it automatically highlights average row size. So that's 20 bytes per row. And there's about 66,000 pages in that index. So that doesn't seem too bad. Let's have a look at the other index, which is the one that includes the text. And we look here, and the row sizes are now 316 bytes per row. So that's, 20 times bigger. And there's 1 million pages instead of 65,000. So that's a lot bigger, and that's a lot of disk space to use for what's a marginal performance improvement. So in this case, I'd be just using the one without the text, and in most cases. But this is one of those things where you would say it depends. If 99% of my queries were that particular query, it's worth wasting a little bit of extra space on disk to make almost everything the server does faster. But it's a trade-off. Okay, so we've now seen how we can write indexes to cover a whole bunch of SQL Server situations, and none of those were terribly tricky to actually to design, were they? So that's pretty much all we've got to cover tonight. And before we go, we'll do a quick summary. So what do you want to do? What are the key things to do? The first one is make sure you visualize your indexes. So understand what the server is trying to do when it's executing your query. Second, use that particularly when you thought you created a great index and it really didn't pan out the way you thought. Try and visualize that index and try and run a query in your head using that index and go, oh, I see. Yeah, it was I've got the 2 columns around the wrong way, or something like that. Or it needed that other column first as the first step of the process, and I forgot to put that one in. It's generally quite easy to see it when you visualize the query and actually try and do it yourself. The second one is, you saw every time I did one of those, I picked out a bunch of candidates or index candidates, and then I created all of them, and then I tested them, and before that I would see which one SQL Server chose to use by default, just to see whether it's doing a good job, and then testing them using that hint. And then finally, make sure you set statistics IO on. That's the golden rule here, so that you can easily figure out what the improvements you're going to get are and how much improvement you're getting. So that gives you the ability to quantify things much better. And then finally, remember to drop any indexes that don't make the cut. So if you're not going to use the index, don't keep it. Remember, selectivity isn't just uniqueness. It's about what % of an object is matched by any given clause. Like your where clause. your join relationships, what order bys and other clauses you've got, especially things like top. So isolate portions of your query and run them separately to see how many rows match each of the bits. And that gives you a better feel for what's going to happen when you run the whole query. The other thing to remember is, and we saw that with that last one, I talked a little bit about it, pick index that cover more of the queries you're going to run. So rather than creating 10 indexes that are perfect for each of 10 queries, you might be able to get 2 indexes that gives you reasonably good performance for all of them, and that would be better if you're doing a lot of inserts and updates of those tables than having only having 10 indexes. And really the key one there is don't go too specific in your index, except for those queries that really are the ones that are causing all of your issues. If your server spends 99% of its time on one query, go the extra mile, make that query super optimal, because that's all that your server is doing pretty much. You may as well, cater to that. Okay, so let's talk about a few resources. And the best resource I think in the industry these days is a presenter. His name's Brent Ozar. He's got a website called brentozar.com. He does a whole bunch of videos. He's got some free training, and then he's got some paid training. The biggest blogger in sort of SQL Server performance is a guy called Penal Dave, and he blogs at SQLauthority.com. He's pretty good. And then there's an annual conference called PASS. That's the Professional Association of SQL Server. And they've got a video library from their conference 2 years ago. And that's a great resource on all things SQL Server. And SQL Skills are also a very good resource. That's run by a husband and wife who spend all their life purely on SQL Server performance issues. There are lots more. Stack Overflow is a great resource. And the one thing I really will call out is the demo database I've used here is the Stack Overflow database. That's originally sourced from the link there, but Brent Ozar, who was the first resource I mentioned, he keeps a ready-to-deploy SQL Server database of that. And that's super useful because you don't have to try and take that other download and transform it into something to put into SQL Server. And he's got various sizes of that. So he's got one from about 2009, which is tiny, and it's good for learning SQL on. Then he's got that SQL Server 2013, Stack Overflow 2013, sorry. And that's got a good size for doing SQL Server performance tuning on. And then he's got one that's pretty much up to now and is monstrous and gives you a good way to benchmark servers and things like that and really test out performance. And it's super useful having those resources. So thank you to Brent Ozar for keeping them up to date. That's very useful for the community. And here's a couple of things that if you want to learn a bit more, these are particular ones that I think are super useful, particularly the first one, Brent Ozar's Think Like the SQL Server Engine. He does a lot more of that sort of, he makes you print out 5 pages of a book and then do a whole bunch of how SQL Server will work with those pages and stuff like that. And then the second one is Sagable expressions, which is some of the expressions you can write in where clauses can be compressed and optimized by SQL Server and some can't. And that's the second biggest sort of performance improvement you can make in my view. So have a look at that once you've mastered everything that we've covered here. All right, so now to some points. So if you'd like to scan the QR code there, you can get some SSW points and maybe get yourself a band like that, or our water bottles that'll tell you the temperature of your drink. They're great little prizes. As well, I love feedback, so please do scan the QR code there and fill out our survey. Tell me how I did. I'd be very interested to hear. Okay, and thank you everyone. So, does anyone have any questions?
Oh, I have to wait for the server. All right, thank you very much, Bryden. Thank you for preparing that. An oldie but a goodie. I remember doing a lot of these things way back. I'm trying to think, early
Yes,
1990s. And it's still relevant, so databases last forever. There is a bloody lot of questions there, so I'm going to start with, I'll start with some fun ones. Somebody that doesn't want to understand everything that you were teaching tonight. Can we just index everything? What's the cost of indexing?
Well, I mean, the cost of indexing is every time you update or modify that table, you've now got to keep those indexes up to date. So
the answer is yes, you can index everything.
Oh, yes, you can.
But when you save a record, instead of waiting a millisecond, you'd be waiting for a long time while everything gets indexed. So it could be expensive.
Yes, and it's got to lock every one of those indexes as it does it. So it's actually very expensive.
Yes, if that was the answer, you wouldn't have this session. All right, this one's a good one too. Should every team have a database expert for optimizing databases? Or can devs watch a video or instructions on optimizing a database? They could watch your session.
Yeah, pretty much. It's very rare that you'll need more than this. So yeah, I think what I've covered here is pretty much enough for a dev to get started. You may, in the occasional project, need some extra expertise, but that'll be relatively rare.
So this is a little bit of a Scrum question, and it's a little bit like sometimes in a team you'll need a sysadmin to help with a whole bunch of things. If you had a whole lot of PowerShell to be written, or a security expert, you might bring in a technical expert to help you for a couple of sprints. If the product owner's agenda is to get the performance right and you know it's going to take a couple of sprints, then pull in an extra resource like a database expert to help you get through those PBIs.
Exactly, yeah. But typically you probably won't need to.
Okay. So another one here, should we index dates? What about date time, like created on columns?
Yeah, date is a good one. Quite often you do need to index on that. And yeah, you can end up in all sorts of problems where you want, if they want to index on the day and it's got time proportions, or if you want to index on the time of day. So that one can open you a can of worms, and that's where you may actually want to get someone with a bit more expertise, particularly if you're wanting to do unusual things. I mean, the common one is that time of day. They want to pick out the time of day, but they've written it as a date, and therefore it's very hard to pick out that time of day efficiently, and you should have put it in another column.
So denormalize it?
Yeah, potentially.
Okay. All right, some questions here. Amazing presentation, Bryden. Really enjoyed it. What is your advice on the maximum number of indexes per database?
Ooh, I wouldn't be looking at how many per database. Typically, you'd look at it per table. And for most, it depends how much querying you're doing on it, like how many times, what sort of searching is being done. But typically you'd start with a couple and then try and keep it to no more than 3 or 4. But in some situations, the searching you're doing is so varied that you may need more than 4. I mean, yeah, so it's very much tied up with what searches are being done, how many indexes you're going to need.
Isn't there a size limit, like 8094 per record?
Yeah, the index, each row in the index must fit into, I think it's 8K.
Yeah.
Which does mean that, you can't include giant text columns like that one that we saw in the example. Like if you had one that was in fact 8K for every row, that would cause you a problem in an index.
And there's better ways of doing
Yes.
large text anyway. Which leads on to another question. Great timing. When creating a clustered index, does using a GUID have a performance impact compared to a little integer?
It does. And for the obvious reason that an integer is typically a lot less bytes than a GUID. And GUID, the other reason here is that the integers, if you're using the auto-incrementing integer, the advantage of that is that when you do an insert, it's always at the end of the index. Whereas if you're doing a GUID, it's effectively a random number being inserted into a list. So you've then got to find where it is and maybe move stuff out the way to stick it in. So it's much less efficient to use a GUID. But Optus showed us why you might want to use a GUID, didn't they? With their data leak, where they had the auto-incrementing integer and you just went through and grabbed every user one by one because you knew what the next ID was.
Oh yeah, that was crazy. I'm going to let someone jump ahead of the queue, Nadine in Melbourne. Can we reduce the cost of indexing by using fill factor option?
Yes. What that one does is it says that's controlling how much of a page has to be full before it'll split. And by doing that, that's where the inserting of GUIDs, where they're going into pages, means you're not as often having to split pages.
Have you done this? How successful is it practically?
I haven't ever had to
so it's
to
not
worry
common.
too much about fill factor.
Right, okay. All right. Now, all right. You mentioned a number of ways to view query plans. Why don't you use SQL Server Profiler to review query plans?
Now, I haven't looked at recent versions of SQL Server Profiler. It may give you back may let you visualize the plans.
Yeah.
Back when I used to use it, it didn't.
Yeah.
So you would get back the plan as a piece of XML and you'd have to read it yourself. So that's why I'm in the habit. I haven't looked at whether it does or doesn't, but I find query stores much more what I want anyway. I don't have to run the profiler and then...
Okay. Do you use SQL Server Profiler and its filters to debug performance issues?
You can. Like that's where you know that you want to feed a normalized workload through, but in my view, query store is actually more useful now.
Right.
Because if what you're profiling and you're getting everything with that, and you're getting it at almost no cost, but you do get more things to filter on in Profiler, so you can put more filters in and you may be able to find what you're looking for more easily.
Yeah, I think a common scenario would be, holy moly, the database is so slow. What's doing it? Where's it coming from? Let's put Profiler on and watch all the different systems attacking this database. Oh, that's the expensive one. Then get over into Query Analyzer.
Yeah, but what you could do is come in, go to Query Store, go what consumed the highest percentage of my SQL Server in the last 20 minutes, and it'll give you the query. You then have to figure out where the query came from.
Right.
So you're sort of doing it, they're giving you the opposite effect. It's harder to find which application it was from Query Store, but it's harder to find the query you want from Profiler.
Right, okay. Well, I think that we've answered this, but so we're getting it again. Why, again, is it bad to use many indexes? Well, we kind of covered it, but the reason is because when you write a record, a whole lot of indexes need to get updated. so it's an expensive,
Yeah.
cost. If it's only a data warehouse, then there's no troubles doing that. Another question, Penny's asking to push ahead. Is there an implication on logging when rebuilding indexes?
I can't remember offhand. So what happens is all of these things are written into a transaction log, and I can't remember if when you rebuild an index, it actually writes out all of that information into the transaction log. I suspect it doesn't, because the real use for that transaction log is for replication or for replaying what's happened. So you would what order the index is in is not actually that important to the table once it's been replicated. So I think it wouldn't have very much effect.
Sorry, clarifying. They didn't mean to say logging. They meant to say locking.
Oh.
Yes. So
yes.
while it's rebuilding indexes,
yes, it will lock the whole index, which may mean, depending on, let me think through the exact answer. The answer is yes, it will have quite an implication. And
right. Okay, so I'll have to stop these questions. They're coming thick and fast. Should I ever use with index equals curly braces and index?
No. Well,
for improving performance in a production query, or because they saw you doing that, is that purely for testing?
That's for testing. There's a couple of reasons I wouldn't do that. One, if certainly in modern SQL Server, you can get it to automatically generate indexes based on your usage. If you've turned that on, that introduces two problems. One, if SQL Server decides that index is useless and removes it on you, you'll get an error, so your query won't even run. But the other one is if you or SQL Server were to add an index that was better than the one that you've insisted on, you might get worse performance. So you've got two potential bad things from doing that.
And the other thing is your data can change over time, so all of a sudden you think you're smarter than the index. Than SQL Server. So you've locked it onto this, but your data has changed and now it's not being as smart as it can. So don't do that in production. Next one. How do I extrapolate SQL queries from my EF core code to test the performance and try out indexes?
So this is one where there's a quick and simple answer, which is, you may remember I said, Unearth Kafka, JK, has great presentations on Entity Framework. He tells you exactly how to do that. And there is an EF Core way to tag queries so that you end up with a comment in the query that you can easily identify on the SQL Server side. So the query's got a comment in it, and you just look for the comment and go, oh, that was that command. And that's a great way to do it.
And I think this is about using any framework. It makes its own SQL, sends it over. Have you ever tried looking at that and going, oh, that's ugly. It's probably not even meant for human. They never intended it to be read, and then tried to optimize it. What's that process of?
Well, with Entity Framework, quite often what you do is you look at the query that you got, and you can get Entity Framework to log the query on the way out as well. So you may not even have to look on SQL Server to figure this out. You look at the query and go, oh, wow, I thought I was asking for the count of that, and that's got a select star from in it. That's not getting the count, that's getting the whole table. Okay, that's why that one was bad. So you can see a whole lot by thinking through, if you know what the command was, comparing the SQL that you got and going, does that do what I think it does? Yes, no. That's a very good thing to figure out whether you've made an error in your query.
Now, on that topic of Entity Framework and SQL Server and performance problems, we've had a lot of requests to run a course on that, or more detailed than along the same lines of what we're doing tonight. So we have these Azure superpowers and .NET superpowers and Angular superpowers. We've done a fair bit of thinking and work on making a database performance superpowers, which includes any framework and that stuff. So we have If I have multiple common queries on a table that retrieve different sets of data, how do I decide which query to optimize using indexes? And I think this is about, if I add this index, it makes this other bit a bit slower. If I add this other index,
Well,
how do I weigh that up?
if it's for only about read, it won't make the other queries slower, it just won't enhance them. So what you would look for is the index that enhances the most used query or the most used queries.
But
So
what,
for
if,
instance,
what if you have two complaints about two things that are slow?
yeah, first thing I would look at is there anything common in them? Like, is it indexed on, say, display name first, and I can just index on display name and then optimize for the second one in the query and get one of them really, really good and one okay. Otherwise, yeah, maybe I do need two indexes.
Right. So adding one index is not going to affect the other one and make that any slower.
No, it won't make the read performance of the other one slower. It will make write performance slower if you have to add a second index.
All right. So I might take this as the last one because we've exhausted you. How about optimizing using temporary tables? Is that ever useful?
Yes. And your mileage may vary here. What you would typically do is if you've got a subset of data that you're going to have to join to consistently, you may want to read that out into a temporary table, which is basically another table. You're just storing it out into there, so partial results of part of the query, and then joining against that because it's going to be much more efficient than SQL Server having to keep everything in memory. Or it may have to spool it to disk, at which point it gets super expensive.
Yeah, now
So that's why you might
temporary
want to
tables that write are very expensive. You can actually return a table type,
Yeah.
which can save you writing, which is pretty good, or way faster.
Can be way faster.
Can be, all right, depending on how much,
So-
yes, and how much memory. All right, so thank you, Bryden. Thank you for putting all this together. That was fantastic. A lot of work goes into this presentation. He's got so many years of experience, and yeah, it's awesome that you put this together. So I'll say good night to all the live audience and the viewers. This is Adam Kogan signing off for SSW TV.